Hi everyone, welcome to Caltex Academy. Today on our board, we have some questions here of integration of even powers. In our previous video, we looked at also even powers, that was power 2, and today we are upgrading the power to power 4. So here we need to use a simple rule, and that is power reduction rule, that can be used to sort out this kind of question. So if you have like cosine to the power of 4, then the reduction rule here would be sine of any angle to the power of 2. For now, let's say theta. This is equivalent to 1 minus cosine twice theta. If the angle is 1, you can double it. If we have here 2, then doubling 2 becomes 4. So all over 2. That is another option of writing this question or this rule. Another way of writing it, you can also put it down here. Like for instance, we had here cosine. So when you have cosine square theta, we can have this as 1. For cosine, we need to add, and we have cosine also of 2 theta, and everything is divided by 2. So these are the two rules that are used for reducing these powers in this scenario. And since we have this to power 4, we need to reduce this to power 2 so that we obtain something similar to sine square theta and cos square theta. So with all this said, let's move on and take a look at this first example here, where we have the integral of cosine to the power of 4 x with respect to x. This we can write it as the integral of, now in terms of cosine, we'll have here cosine square x, and we can raise to power 2 like that, and this is with respect to x. Now we know that cos square theta from our power reduction rule here is 1 plus cos twice theta over 2. So let's do that here, and we have this is equivalent to the integral of, let's maintain our bracket here, and we have 1 plus cosine of 2x, since we're integrating with respect to x and everything is over 2. Now we can close this, then raising this power to 2. So with also respect to x. So after this, we can distribute this power to these two numbers, both the numerator and the denominator. Like if we have written this power rule down here, where if you have a over b exponent n, we can rewrite this by distributing this n to a as the numerator and also b as the denominator. So for now, we are at this stage where our common power is 2. So we need to distribute it to the numerator and denominator. Now let's go on and do that here in our next step, where we have the integral of, so let's keep on maintaining our bracket. And here it is also a good idea if we create a new bracket for the numerator, because it's more than 1 terms. So we have 1 plus cosine of 2x, and we close this bracket. This time we can square it, so we have our square here. Then we divide this with our denominator, and that is 2. Also we can distribute this power to the denominator and that is square. So let's close this bracket, and we are integrating with respect to x. So let's get more space for our working. Now let's go ahead and expand the numerator and also expand the denominator. So a square of the denominator is going to be 4. So we can pull it out as 1 over 4 multiplies by, so here we will expand this, and of course expanding this kind of identities, like if you have a plus b and you square it, the easiest way of working out this is you square the first term and then we square the last term, that is b square, and of course whether positive or negative, this results always to positive. Then we double all this, so we have 2 times a is 2a times b is 2ab. So applying this expansion in our work here, we'll have 1 square is 1, and we can double them, so we shall have here plus twice cos of 2x. Then when we square our last term, that is cos 2x, we shall have here cos square 2x. And since we've also gotten a term here with square, we can repeat the same scenario of this substitution we have done earlier on here. So this is with respect to x. Now before we integrate these 2 terms which are already ready, let's first finish with this and then integrate once. So here we have 1 over 4 integral of still our 1 here, that is 1 plus 2 cos of twice x. Now this one we can say the right our, another way of writing this would be we pull out 1/2, so we can have here 1/2 into 1, and for now, as we have written earlier on, if it is cos, we have addition here, so we shall have here plus cosine, and now the angle was 2x, so this time we can double 2x to 4x. Then we close up this bracket and we are integrating with respect to x. So we have here dx. Now after writing this, we also need to open up that bracket. So here we'll have, let's keep on maintaining our 1 over 4 outside here, and still our bracket is still waiting for us here. So we have the first term, that is 1 plus twice cos of 2x. If you open up this bracket, the first term becomes 1/2. Then the second term here becomes 1/2 cos 4x. So again, let's close this bracket up and we're integrating with respect to x. If you need one more step of simplifying these numbers, you can go ahead, but let me just work it out and immediately we shall simplify after integrating. So we shall have here 1 over 4. Now, since we're integrating, we remove this sign off, and the integral of 1 with respect to x is just simply x. Now, here we will add our 2, but we need a special bracket here such that if you integrate cosine, you get sine, and we maintain our angle, that is 2x, but then we have to divide by this 2, which has attached itself to this x. So we have here that we close up the bracket, and we can also go ahead and integrate Next term here with respect to x, since it is constant, we just simply attach our x there. And let's repeat the same thing I've just done here by writing this constant out and also create our new bracket here. Then we integrate. Our cosine goes to sine 4x, also dividing with this coefficient 4. So let's close that bracket up, and we are done with this integration. But then we had this 1/4 that is going to multiply every term, so we have to also finish it up by closing up this plus constant of integration. So we're just left with opening up this bracket, and finally we will be done. So if you open up this bracket, the first term here becomes 1/4 x plus, now you can see here that this one can also cross. We're left with sine 2x. So we have here sine 2x. Now the next one here, sorry, because we need to also multiply by this, we need to have this 1/4 attached to this term here. Maybe let's use a different color, and that is the green color here, because we have started it with green color. So 1/4 comes in here. Now plus, again, this time we need to multiply 4 and 2. So we shall have here 1/8 x plus, so before we open up this bracket, we need to multiply by 4. So 4 times 2, we get 8. 8 times 4, we can have 32. So we shall have here 1/32 times sine 4x. So this is our solution plus our constant of integration. So our question was the integral of cosine to the power of 4x. So when you integrate that, your solution is simply, this implies that the integral of cosine to the power of 4 of x with respect to x will just give you this. And that is how we tackle this kind of question. So if you have some question about this working, drop it in the comment section. I will get back to you and answer you wherever necessary. So let's take a look at also the second question. And our second question is, we need to get the integral of sine to the power of 4 of 3x. So for sine, we use this first approach here, that power reduction rule that deals with sine. Now let's get enough space and work out that. Yeah, so in this question also, we can do it in the same way, where we first need to rewrite this in terms of sine square. So we shall have here the integral of, now this time around, we can open up this bracket and we have, maybe let's try square bracket, and we have here inside this bracket our sine square 3x. So again, this is squared, and the reason why we have to square this is to be able to come back to our 4 here. This is based on the exponential rule that if you have a number raised to power again to another power, all these powers or the exponents multiplies themselves to get back that. So we have this with respect to x. Now again, we already know on what to do here. Let's go ahead and do that by substituting sine square 3x with So let's maintain our square bracket here, and at this stage we have 1/2 into 1, since it is sine, then we have minus here, so we have cosine of, now we have 3, and the rule says we have to double this, so when you double 3 you get 6. Now here all this must be squared, so we have to also still place our square bracket here, and we place our square there. Then we are doing this with respect to also x. So let us distribute our square to these two terms. The first term here is 1/2. Now when we square 1/2, we can pull it out as 1/4, and we are integrating this with, so let's go ahead and also expand this directly from here. So we know that we have already the first term as 1 minus 2 cosine of 6x plus, when we square this term, which is the last one, negative cos 6x, we shall get just cosine square of 6x, and that is the expansion of this second term here in this bracket. Meanwhile, the first one is what we have just pulled out here as a constant. So we're integrating this with respect to x. Now with this, we can now move on and also replace the second term here, reducing its power from 2 to 1. Now let's do that in our next step here, where we have 1/4, the integral of, so let's maintain our first two numbers here, and that is 1 minus twice cos 6x plus, now the next one is 1/2 into 1, and because it is cos, we can have addition here, and again we still maintain our cos, but the power can reduce from 2 to 1, and the angle will double to 12. So I'll have here 12x, and we are done with that expansion. So let's close up this bracket, because our 1/4 is waiting to open up that bracket. And if you wish, you can also go on and open up with this 1/4 before integrating. So to reduce our work, I think it's better for us to first deal with this small number and it's open later. So we have 1/4, the integral of, let's maintain that bracket, and we have our first two terms as before, twice cosine of 6x plus, now when we open up this bracket, we still get our 1/2 plus also 1/2 cosine of 12x. And since we have expanded earlier on in our previous question, I said you can also do one extra step by first of all combining them together. So let's do that in this question, where we still maintain our 1/4, the integral of, so if you combine 1 plus 1/2, you get 3/2. Now we have here minus twice cosine of 6x plus, so we are left with only this 1/2 multiplied by cosine of 12x. And from here, we have really simplified our question here. That is going to be easy to integrate. So let's move on and integrate. So we have 1/4 is gonna multiply the integral of the first term here is just simply attaching our variable x minus 2, and let's open up another bracket because we're going to integrate what is here, and that is cosine of 6x. So the integral of cos 6x is also sine 6x over 6. Then we can close up that bracket and we can move to the next one, that is plus. We can also maintain our 1/2 and continue with this bracket here, where we have to integrate cosine 12x. That becomes sine 12x over 12. Then let's close these two brackets. The first one is for this term, and the last one is our square bracket, which will be used for opening up our coefficient here, 1/4. So let's move on and first of all simplify what we have here such that we don't have too many things to work with. So let's first maintain our 1/4 multiplied by the first term. Has no problem, so we can just simply copy it, and that is 3/2x. Now minus, so we can see here that okay, we can divide 2 by 2 goes 1, and then 6 by 2 goes 3. Now here, these are denominators, we just simply multiply them. So what we had here is 1/3 sine of 6x plus. Now here we can multiply the denominators, and we have in the denominator 24. Term is sine of 12x, and we can close up this bracket plus our constant of integration. So from here we are free to open up this bracket. So as we open up this bracket, I think we get the same answer already. So we can go ahead and say, okay, the integral of cosine to the power of 4 of 3x with respect to x is equivalent to, so there's nothing that cross here, we just simply multiply the numerator to 3 and denominator to 8x minus, when you open up the bracket, we have here 1/12 sine 6x plus, if we open up this bracket, then we have something to multiply here, that is 24 by 4, and we know when you multiply 4 by 4, we get 16, we have a 1, this is 8 plus 1, that is 9, so we have 1/96, and that is sine of 12x plus the constant of integration. So this is the solution for the second question. If you have gotten some value from this video, consider subscribing to the channel and then share with friends. See you in the next video where we shall look at power 6. Peace out.